In this video, we will talk about the parent functions. We've been talking about different types of functions and doing a lot of things algebraically, but this time we're going to do things graphically. What I have here is basically the parent function and what it kind of looks like, what the shape looks like. One of the things that I want you really to know is there's a lot of information here, but you definitely know the domain and the range, of course. But one of the things to really kind of consider is that um, just given a particular graph, like for example, the parabola y equals x squared, just know what the graph looks like. This is just a parabolic shape. Okay, so you can find these graphs on Canvas. I posted them, so you can go ahead and take a look at them. Really be familiar with them. Some of them are pretty easy. You can kind of just look at them and be like, oh yeah, I know that one. But there's others ones that maybe you didn't know. So for example, like the cubed root, maybe you didn't know that it kind of looked like an S shape. There's other ones that we're going to take a look at later. Right now, I want you guys to be able to be familiar with the ones that are above the cubed roots. Okay, be familiar with these guys for right now. Also, be familiar with these guys also. I don't care about that one. This guy too. This guy's good. This one, later on we'll talk about this one too, um, but for the most part, the ones that I circled really understand and be able to see the picture and know what the shape kind of looks like. I think that's going to be really helpful. I don't really care about this one. You can cross that one out. This one's just basically the representation of a constant, which we'll talk about in the next chapter. But yeah, really understand these guys. Okay. All right. So now, what we're gonna do is we're going to do function transformations. If you want to pause the video, you can do so here. These are basically rules on how to shift and and compress and reflect a function. So if I give you a function and I add a value of it outside of it. So see here how I'm adding a k or subtracting a k. Well, when I add a k, what that's doing is I'm vertically shifting the graph k units up. Okay? If I'm subtracting the k, I'm shifting the graph down by k units vertically. Now here's where the weird part comes in. Whenever the number is inside of the function, it does the opposite, okay? So here you think that it's going to be going off to the left, but no, it actually goes to the right. Same thing with the plus h. It's not going to go to the right, it's going to go h units to the left, and all of this is horizontally, okay? When it's outside, it's still going to do the same thing. Here, think about f of x being the y value. So basically, I'm stretching the graph, so I'm multiplying the y values by a factor of a. Here, when you divide by a, or you're multiplying by a fraction, you're compressing the graph by a factor of 1 over a. So you're multiplying all the y values, which is basically the f of x, by a factor of 1 over a. So you're kind of compressing it. Now, when it's in the inside, it doesn't follow the rules, okay? So it's doing the opposite. So here in this case, you're compressing it by a factor of 1 over a, so it's doing the opposite of what you think will do. So now, in this case, the x's are being multiplied by 1 over a. Here, 1 over a is doing the opposite again, multiply the x's by a factor of a. Okay, so whenever it's in the inside, it always does the opposite. So these guys are the ones that are the weird ones. Okay, everything else is pretty good. Then when you have a negative on the outside, like this guy, you basically are reflecting the graph about the x-axis. So imagine that the graph looked like this, and then there was a negative. So now instead of a happy parabola, you're going to have a sad parabola. So you have a reflection across the x-axis. If you have a negative in the inside, it's a reflection across the y-axis. So let's say, for example, you had a cubed, something that looked like that. So now what's going to happen is you're going to reflect across this guy. So now this guy that you see here, now is going to be over here. And now this guy that you see on the bottom, now it's going to be down here. So you kind of are reflecting it, okay? So you're shifting everything around. So that's what it means to be a reflection across the y-axis in this case. So make sure that you really know these, okay? So what we're going to do in this video, we're just going to practice doing a whole bunch of different problems using our good parent functions. And later on, we're going to be talking about absolute values, linear functions, and quadratics will be actually the next in 2 chapters from now. We'll talk a little bit about absolute values because I think a lot of people forget what absolute values really do. Let's do a couple of examples where we're shifting and compressing. Um, so, example. So let's say you want to graph the following function. Oops, functions using the appropriate transformations. Okay, so we're going to start off with f of x is equal to x squared minus 3. Okay, so now what would that kind of look like? So the first thing to kind of know is what is the parent function? Who is the original parent before it got transformed? So originally you can see that you have an x squared, so you know that the parent function is going to be a parabola. Okay, and the parabola has 0, 0. At -1, it's 1. And at +1, it's 1. So this is the original parabola, not the graph that I have for this guy. So this is the original. So this is basically f of x equals x squared. Okay, so that's what it kind of looks like, and it has like a U shape. Now what I'm going to do, I like using these 3 points as reference because that will help me out. Now what exactly is this -3 doing? So this -3, notice that it's on the outside of the graph. So what it's going to be doing is shift down 3. So that means that everything is going to go down 3 units. So initially this was at 0. I'm going to go down 3 units now. So I'm at -3. This guy, this point right here, and these points are going to go down 3 units. So initially they were at 1. Now they're going to be at -2. So where they were at before, -1 and 1, now they're going to be down at -2 and 2. And now we're just going to sketch them. Okay. So here, that's basically the graph. Okay. Ta-da! That's basically all it is. Okay. Now, I suck at drawing, so I'm trying my best to do it. And I like to draw these reference points because these are going to guide me through them. Okay. Now, if you look here, the domain and the range, I know the problem didn't ask for it, but it's a really good idea to kind of do it. The domain here is going to be -infinity to +infinity, and that makes sense because this is a polynomial. So it's from -infinity to a +infinity. Okay, now the range here is going to be the y values, and we haven't really talked about the range much, but you can see that what is the lowest y value that this can be. So here's the y value. The lowest one here you can see is -3, and -3 is included because there's a point there. So it's going to start from -3 all the way up to infinity. That would be the range. Okay, all right, let's do another problem. Okay, so let's say we had g of x is equal to 3 absolute value of x minus 2. Okay. Now, typically what I like to do first is I like to start from the inside out. So kind of like if you had like a lot of stuff like f of x minus h and then a plus k. So you had a lot of things that happen. I like starting with the inside first and then circling around till the end. So I like to do the h first, then if there's something in front of the x, then the a, and then end with the k. So I like to start from the inside and then out. So in this case, I like to do the -2 at the end. So first, let's start off with thinking about the parent function. So the parent function in this case is going to be this absolute value of x. And the absolute value of x looks like a V shape. So it still has the same reference points, -1, 1, and 1. So it still looks a lot like the parabola, but in this case, it has a V shape. So it looks like that. Okay, so now what we're going to do is we're going to take this 3. So now this 3, basically what it does is going to stretch the graph. So basically what you're doing is you're multiplying every single y value by that number. So here are the y values. I'm multiplying this guy by 3, this guy by 3, and this guy by 3. Okay? So what's going to happen? So this y value right here is 1. So when I multiply it by 3, it's now going to be a 3. Okay, so at -1 and 1, that one's going to be stretched up to 3. This guy is also going to be stretched out to 3 because you had a y value of 1. Now this guy's 0. When I multiply this by 3, it's just going to be 0. Okay, so basically you can see that you have a stretched up V shape. Okay, so now we just stretched it up. It's now much faster. And now the last thing that you want to be able to do is just shift this guy 2 units down. So I'm going to go 2 units down. So I'm going to have at 0, you're going to go 2 units down. Okay, so now it's there. I was at 3, I'm going to go 2 units down. So now I'm going to be at 1. So I'm back kind of where I started at. Okay, so my graph looks like this. Okay, so if I wanted to find the domain is going to be from -infinity to +infinity, because absolute values, you can plug in anything that you want in the absolute values. And then the range is going to be from the bottom part, which is -2 included, all the way to infinity. Okay. All right, let's do another one. So let's say we had h of x is equal to the square root of x plus 2 plus 3. Okay, now square roots can be a little tricky to start with graphing it. So what I like to do, let's start off with the square root. So we know that the function should be a square root of x. Okay, so a square root of x kind of looks like a hook, so it starts at 0, and then at 1 you have a 1. Okay, because the square root of 1 is 1. And then we don't do the 2, because then if you do the square root of 2, it's kind of weird. So let's just write it like this. Okay, let's say that's basically the square root function. So the first thing that you're going to do, let's start from the inside out. So we're going to start off with the 2. And then after that, we're going to do the 3. So starting with the 2, this 2 says that I'm going to do the opposite. So I'm going to move to the left 2. Oh no, that's wrong. I'm going to move to the right, to the left 2. Yeah, left 2. So I'm going to move to the left 2 units. So this guy is going to go to the left 2 units. Okay, and it's horizontally. Okay, so initially this guy was at 0. I'm going to move 2 units over. So now I'm at -2. Okay, this guy is right here. I'm going to move 2 units over. So now I'm at 1, -1. So I'm right there. Okay, so this is the graph shifted 2 units over. Okay, so you kind of have to have some perspective. You kind of want to be able to keep track of these numbers. Okay, then you have this +3. Remember that this +3, what it does is going to move it up 3 units. Okay, so I'm going to move everything up 3 units. So right now this guy is at -2 right here. So I'm going to move up 3 units, 1, 2, 3. So now instead of here, it's going to be right there. This guy is right here. I'm going to move up 3 units. So it was at 1, moving up 3 units. Now I'm at 4. Okay, so the graph looks like this. Oh God, terrible. Okay, and that's it. Now, I don't like drawing it in the same graph because it gets really messy, but this is basically what you want to be able to do. Okay, let's do some more. Let's do a negative. Then let's do an let's do a 2 here. 2x plus 1 cubed minus 1. Let's say we had something that looked like that. Okay. Okay, so we're going to start off with what the parent function looks like. So the parent function is a cube. Okay, so kind of looks like spaghetti. And looking at the reference, it's kind of the same, but just as a parabola. But it's kind of the opposite now. They kind of form like a line, but it kind of looks like, like this. I don't know. Okay. All right, so this is what the cube looks like, and the reason why I know cube is because it's a 3 there. Now let's start off with the inside out. So we're going to start off with the 1, and then we're going to work our way out. So that 1 means that I'm shifting everything 1 unit to the left, okay? So let's start off with that. So 1 unit to the left, okay? So this guy right here is going to go over from -1 to -2. Here's -1. Okay, 1 unit to the left, that's going to be here. 1 unit to the left, now it's going to be here. Okay, so now this graph kind of looks like this. Oh God. Okay, so it looks like that. All right, now the next thing that I'm going to work with is this 2. Now remember that this 2, what it does the opposite. So you're going to multiply all of my x values by 1/2. Okay, multiplication by 1/2 2x values. Okay, so you're going to look at all my x values that I currently have. So here, the x value that corresponds with this guy is -2. So when I multiply that by 1/2, I'm going to get just 1. So this guy in purple is not going to be now at, it's not going to be a -2 anymore because I multiply that by 1/2. That's going to be now 1, a -1. So that point right here, this purple one, is not going to be a -1. Because this times 1/2 gives me -1. All right. Now let's look at this one. Let's look at this point. This x value on the x-axis is -1. So when I take -1 and I multiply it by -1/2, I'm sorry, +1/2, you're going to get -1/2. So that point now shrinks to that point right there. Okay. And now finally, we're going to look at this point right here. On the x-axis, this is 0. So when I multiply this by 0, okay, you're just going to get 0. So that one stays at the same spot. It's just 0. Okay, so if you can kind of see, this graph kind of shrunk. Okay, I suck at drawing, but it kind of shrunk. Okay, so now I dealt with this guy. Now the next thing is this negative. This negative means reflection. So everything is going to be swapped across the x-axis. Okay, so now this is going to be, so now we're swapping everything. So now instead of a 1, guess what? Now you're negative. Okay, now you're -1. Okay, this guy, well, this guy's right on the axis, so it's going to stay there. -1/2. That guy stays there. And this guy was at -1. So guess what? Now you're at +1. So at -1, +1. Okay. So now, oh God, here I go. It looks something like that. Okay. So now you kind of just, you flip them around. So now I check this one. Now the last one is this -1, so which basically means shift everything down 1. Okay, so down 1. Okay, so this is gonna be down 1 unit. So right now, this guy right here is at -1, 1. And I'm gonna shift this guy 1 unit down. So now I'm gonna be at 0. Right? Is there one? Yes, this one. Okay. Now this guy right here is at 0. I'm going to shift 1 unit down. So now this guy's at -1. So at -1/2, it was at 0. Now you're shifting it down. And then this guy was at -1. I'm going to go down 1. It's going to be at -2. So my graph looks something like this. Oh gosh. Looks so ugly. Okay, now you don't need, obviously, as long as you give me these points, I'll be really, really happy. Okay? And I don't really care so much about your graph itself. I mean, you have to shape, but you can see that I'm not a really good drawer either. So as long as you can give me something that looks like this, you should be fine. The domain and range is just in all real numbers. But this is just basically the gist of it. Just follow it from the inside out, and you should be completely fine.